Hello, everyone. My name is Vicente Amado. I'm a second-year graduate student at Michigan State University, and I'm very excited to share my work on the development of a global registry for peer review in astrophysics. This work was done in collaboration with the Space Telescope Science Institute, and the team working on this were myself, Lou Schroger from Space Telescope, and Wolfgang Kirsendorf, my advisor. Innovation and the growth of the world have created new challenges across all fields, but I will specifically talk about the effect these challenges have had on peer review in astrophysics. So in astrophysics, the allocation of resources such as grants through NASA and NSF undergo a very similar process to all other fields, but the allocation of community facilities such as telescopes undergo a different process, which they must be shared amongst researchers to perform their experiments. And this is unique to astrophysics. And so the growth of the worldwide astronomical community has created new challenges in allocating these resources. So an open source reviewer registry to expand the reviewer pool has been presented to alleviate some of these challenges. And an important element of the review registry is the problem of ambiguous author names. So I will talk about an author name disambiguation method and how we validated it using real author data. So the growth in the worldwide population has led to a natural growth in research. Specifically, a UNESCO science report found that researchers worldwide grew by 15% in only 4 years. And this can be tracked in astrophysics through the membership of the International Astronomical Union, which has grown from only 207 members in 1922 to over 14,000 members today. And in parallel, early on, a majority of telescopes were built by individual research groups for their specific research questions, such as the Hopkins Observatory in Williams College, one of the oldest in the country. But as the questions became more complex, it was no longer feasible for an individual research group to build their facilities. So the community came together with large organizations such as NASA to build the Hubble Space Telescope and the European Southern Observatory to build the very large telescope, the VLT in Chile. And then more recently, the Transiting Exoplanet Survey satellite, looking for planets around sun-like stars, and the James Webb Space Telescope, observing further than we ever have before. But these facilities must be shared amongst the community. So let's take the very large telescope, the VLT, as an example. So in astrophysics, an experiment is a single observation conducted on a community telescope. It's a community resource that must be shared amongst the researchers to perform their experiments. And so similar to other fields, a researcher starts with a question, continues on with their research and they're forming a hypothesis and onto the experimentation. But in astrophysics, there's an obstacle here. A researcher cannot continue with their work until they're allocated time on one of these community telescopes, such as the VLT. And they are limited resources. So for example, one of the telescopes at the VLT can only conduct one experiment at a time, looking for one researcher's targets at a time. And only a portion of nights have the specific conditions required for observation, such as needing a clear sky, meaning no cloud cover. Therefore, a peer review process was created requiring a proposal for a researcher to be allocated time on one of these great observatories. And so as the worldwide astronomical community has grown and more telescopes have been developed, the great observatories have had to rethink their peer review systems as they have been overwhelmed with proposals. The European Southern Observatory has tracked the growth in proposals and have found that there are currently 5 times more proposals than there were in 1977. And you may be thinking to yourself, if there has been a growth in the worldwide astronomical community and a similar increase in the amount of proposals, why is the system overwhelmed? And that is due to a minority of researchers reviewing a majority of the proposals. This study found that 20% of researchers perform 69% to 94% of the reviews. And this reliance on a minority to review a majority of the proposals causes non-expert reviews, as each proposal is highly specialized. And in astrophysics, being a reviewer is a volunteer activity, leading to pressured reviews, as a reviewer only has a limited amount of time to review all the proposals that they receive. And so combining all the pieces, the number of proposals growing faster than the number of reviewers and the increase in community-owned facilities has overwhelmed the peer review systems at the great observatories. But the increase in worldwide astrophysicists is a piece of the solution. By leveraging the worldwide astronomical community, we can broaden the reviewer pool. So we are presenting our work on a reliable registry for peer review in astrophysics. To build this reviewer registry, we must first locate reviewer information, and it's not located in a simple search. It's located in multiple incomplete sources, such as arXiv, which is a preprint server for many science fields, containing a majority of astrophysics publications. So the expert reviewers can be extracted from the author lists of these astrophysics publications. But a reviewer's name is scattered across their multiple publications, leading to ambiguity in the identity of the different reviewers. And then ORCID IDs assigns an author and identifier that is connected to their contributions. And an author must automatically enroll and actively sign up, leading to only roughly half of researchers in each field to use ORCID identifiers in their work. And then Inspire HEP, which is an open access digital library for the field of high energy physics, has thought about this algorithmically and, like us, are making it open source. They have extended author profiles, adding affiliations, collaborations, and co-authors. But their library only contains a portion of astrophysics publications. This is a good first start, as Inspire HEP has thought about the problem of ambiguous author names. So our registry is compiled by gathering the papers from arXiv, the astrophysics publications from arXiv, and then extracting the author names. But we encounter two problems. Different authors have the same name. Smith appears over 4,000 times and Lee appears over 23,000 times. These common names have a high level of ambiguity, leading to merging of identities. And so this is a problem, as names from different cultures can be disproportionately affected by this and then later on be misidentified as a reviewer. And the same authors have different names. So for example, my advisor appears under W.E. Kersendorf and W. Kersendorf, and this affects the majority of reviewers as they appear with or without their middle initial. And many researchers across their career have name changes. And as an example, in marriage, this can disproportionately affect women. And this is when identities are split. So we researched author name disambiguation algorithms to handle these problems, and as to not reinvent an effective technique, we found this paper, Milojevic 2013, that presented a name-based algorithm that leveraged information solely within the name. And so in Milojevic 2013, a hybrid method was presented based on the initials of the author's name and the frequency of their last name. This was tested on a simulated author data set, as the true identities of the empirical data were unknown. And this left 5.5% of author identities to continue to be ambiguous. And so we wanted to validate this on our data set. And we started by generating a real author data set. So we cross-matched titles from ORCID profiles to astrophysics publications. And this resulted in a database of 20,000 identified astrophysicists connected to an ORCID identifier. And so we used the hybrid method on our 20,000 identified astrophysicists, and it left 2.5 times more contamination of names than Milojevic presented due to splitting or merging. This continued high level of ambiguity has shown us that this method did not appear to work at an acceptable level as to not misidentify reviewers, and so specifically for our real data set of astrophysicists. And so, as I stated earlier, the growth in the worldwide astronomical community and the development of more telescopes has overwhelmed the peer review systems at the great observatories, leading to non-expert reviews and pressured reviews. And one solution that leverages the worldwide astronomical community is building an open source reviewer registry from astrophysics publications. But the current reviewer information sources are incomplete, leading to ambiguous author names. And so an important element of broadening the reviewer pool is having a disambiguated reviewer registry. And so we are now looking into several new algorithms available but not validated for astrophysics. Thank you for listening. Check out a poster that is a prototype in action at the European Southern Observatory.
Thank you, Vicente. Questions? We're also waiting for the virtual questions. Here we have.
Yeah, thank you, Vicente, for the fantastic talk and work. I'm just curious to know here that if, like, how much of this can be resolved by stronger policies? For example, if all of these reviewing bodies say that, hey, you have to, if you want to submit, you have to have and maintain an ORCID ID, how much would that expand the pool?
Yeah, so in a perfect world, ORCID identifiers would disambiguate immediately all the author names in our reviewer data set. But as I stated, only 60% or 50% of authors currently use ORCID identifiers. And so these such policies would immediately make our work much easier. And even just in helping authors maybe have consistencies in the namings they use. So like always use your middle name or never use your middle name, because that causes a lot of problems in splitting and merging of authors, especially with the most common names.
Okay, yeah.
Les Citrome, current medical research and opinion. Thanks so much for your presentation. It's always refreshing to hear about a different field than the medical field. So thank you for that. So we've been struggling a lot with trying to identify authors, and ORCID is only part of the solution. And journals have been kind of not so enthusiastic on the whole regarding it. Some do, some require it actually, or try to require it. Some would like it. And then some want it and then won't let you add it after a certain part in the production process. So it's not well implemented. So that's something to be familiar with.
Yes.
The other is another solution which has been alluded to is having the emails of all the authors available in the publication. But that too is not foolproof. Emails change. I've changed mine. Others have as well. Institutional emails sometimes go to nowhere. And so people have ended up using Gmail, even though they're with an institution. They prefer the Gmail because it's more reliable than their own institutional's email. So these are things to consider. And I'm really curious to see how other fields of science deal with this issue. So thank you for your presentation.
Thank you.
Thank you. We're going to jump to virtual questions first and then return to the ones here. Michael?
Yeah, thank you. Lots of interest online. Stephen Gallo asks how many authors have emails associated with them so you can invite them as a reviewer. Michael Willis from Wiley asks, have you considered using author networks or keywords as a way of resolving disambiguation? And Nick Violet from the American Geophysical Union asks, have you considered partnering with publishers who have cultivated huge databases of experts? So address any of those you can remember.
Yes. So yeah, so for emails, currently we're working with 220,000 papers. And so we wanted to see how effective just a simple name-based algorithm was, as that we know we have names for the 220,000 papers. In our current data set, we do not have the access to emails. That's why we are expanding in hopefully partnering with other libraries such as InspireHep, who have, like I said, extended their author profiles. And I don't remember any of the other questions.
Oh, collaboration networks.
Oh, yes, yes. So
Right.
for the next steps, we are looking into co-author networks to help disambiguate authors, and also looking at, since we have the full text papers, seeing if we can find a similarity between an author's paper to combine all their different papers.
And partnering with publishers who have their own reviewer databases.
We have not thought about that yet. I think since we're just getting started, but yes.
Okay, thanks. Question there?
Yeah, hi, my name's Emily. I'm a librarian at Portland State University. And perhaps the lone social scientist in this room. I have a question. No? Yay! I like that. I have a question about this disambiguation with names, particularly when it comes to folks who maybe have transitioned
Mhm.
and dead names might be on a record. How have you considered that, as well as some other maybe harmful uses of names that aren't in use anymore for people who are
Mhm.
needing protection,
Yes.
et cetera? So could you talk about that a little bit more?
Mhm.
I noticed you had one bullet point that said DEI considerations, and to me, that's a whole presentation. So if
Yes.
you just have any more thoughts on that, I'd love to hear it.
Yes, yeah. So that's why we're looking to have more information, extending our information so that we can know more about each author on the paper. Because yeah, currently with just the names, we can't really understand more than just what's at face value, and we just match the names or we split the names. So that's we are thinking about that by adding extended information for each paper.
And can I ask also a question? Do you have do you use a genderizer? Can you differentiate the gender of the authors in your?
Currently, we do not use
Okay.
that.
Okay, thanks. If there are no more questions, thank you very much.